Next reaction we are going to see is reactions of aldehydes and ketones with sodium hypoiodide. Now here sodium hypoiodide is NaOI, and when NaOH, that is sodium hydroxide, is treated with iodine molecule, then here formation of this sodium hypoiodide takes place. The color of this sodium hypoiodide is yellow, that is yellow precipitate of sodium hypoiodide is formed in the reaction mixture. Now here when these aldehydes or ketones react with sodium hypoiodide, or when these aldehydes or ketones react with or formed with sodium hypoiodide, formation of iodoform takes place. Now there is a condition for this reaction, that is this reaction is given by only acetaldehyde or methyl ketones or alcohols containing CH3CHOH group. That is the aldehydes or ketones which possesses at least one CH3 group attached to the carbonyl carbon. Now here these alcohols also give this reaction. That is, which alcohols gives this reaction? CH3CHOH. Now this is oxidation reaction. When sodium hypoiodide react with aldehydes or ketones or alcohol, they undergo oxidation, and then formation of here iodoform takes place. Therefore this reaction is also named as haloform reaction. That is formation of iodoform, that is haloform takes place. Therefore this reaction is also named as haloform reaction. And here we are going to see the reaction of this sodium hypoiodide with this aldehyde, ketone and alcohols. Now here there is condition that each carbonyl group, that is the carbonyl group is attached to one CH3 group, and we know that only acetaldehyde is the compound, or acetaldehyde is the aldehyde which possesses CH3 group attached to this carbonyl carbon. Now here there is hydrogen atom. Now ketones, in which one alkyl group must be CH3 group, that is this CH3 group is attached to this carbonyl carbon, then it undergo haloform reaction. Or alcohols which possesses CH3 group attached to this CHOH group, then it can undergo haloform reaction. Now in this reaction aldehydes or ketones or these alcohols undergo oxidation in presence of sodium hypoiodide. Now here first we are going to see acetaldehyde. When this acetaldehyde is bound with this sodium hypoiodide, this sodium hypoiodide is unstable, and therefore it is prepared at the time of reaction in presence of NaOH and iodine molecule. First NaOH and iodine molecules undergo reaction to form sodium hypoiodide, and this sodium hypoiodide then reacts with this acetaldehyde to form iodoform. Now how iodoform takes place? How the formation of iodoform takes place? Look here. Now here first this bond breaks and this NaO get attached to this carbonyl carbon from this position, and all these hydrogen atom attached to methyl group or present in methyl group are replaced by this iodine atom. Now here 3 hydrogen atoms from this methyl group are replaced by 3 iodine. Therefore we have to use here 3 molecules of sodium hypoiodide. Now how the reaction takes place? Look here. Here formation of CHI3 plus HC double bond ONA, that is this ONA get attached to this CO group to form HC double bond ONA plus NaOH. Now we have to balance this reaction. Here there are 3 Na. Now here there are only 2, therefore write here 2. Then this reaction is completely balanced. This compound, that is CHI3, is iodoform. And this compound is sodium formate. That is sodium salt of formic acid. Now second reaction we are going to see with acetone. This acetone must be methyl ketone. That is, one alkyl group attached to carbonyl carbon must be methyl group. Then only this haloform reaction occurs. When this ketone react with this sodium hypoiodide, then here formation of CHI3 takes place. That is iodoform plus R C double bond O O N A, that is sodium carboxylate, plus 2 molecules of NaOH. We have to balance this reaction right here. Nice. Then third reaction, when this alcohol, it is treated with sodium hypoiodide, first this alcohol undergo oxidation to form CH3 C double bond O R. That is, alcohol undergo oxidation in presence of this sodium hypoiodide to form ketone. This is methyl ketone. And this methyl ketone then react with NaOH to form CHI3 plus R C double bond O O N A plus here 3 molecules of NaOH are used to form 2 molecules of NaOH. And in this way, formation of iodoform, sodium carboxylate and 2 molecules of NaOH takes place. Now homework for you. Write chemical reaction taking place when propane to OL is treated with iodine and sodium hydroxide. Next reaction we are going to see aldol condensation reaction. This is very important reaction when aldehydes or ketones containing at least one alpha hydrogen atom undergo aldol condensation reaction in presence of weak base like 10% sodium hydroxide or 10% potassium hydroxide, or in presence of sodium carbonate or sodium bicarbonate, gives beta hydroxyaldehyde, that is aldol, or beta hydroxy ketone, that is ketone. This reaction is named as aldol condensation reaction. Now we are going to see the detailed reaction. Now here first we have taken the example of acetaldehyde. Here this acetaldehyde, that is CH3 C double bond OH. This acetaldehyde possesses alpha hydrogen atom. Now we know that what is meant by alpha hydrogen atom. The carbon atom which is attached to carbonyl carbon is called as alpha carbon atom, and the hydrogen atom attached to this alpha carbon atom are called as alpha hydrogen atom. Now in case of acetaldehyde there are 3 alpha hydrogen atom, and when both acetaldehyde molecules, this is one acetaldehyde molecule and this is second acetaldehyde molecule, when these compounds are created with or formed with 10% NaOH, that is in presence of mild base, then here aldol condensation reaction is carried out. This is simple addition reaction, and in this reaction one molecule of aldehyde gets added into the carbonyl group of second molecule of aldehyde. Now look here, this is first acetaldehyde molecule and this is second acetaldehyde molecule. In this reaction, one alpha hydrogen atom of second acetaldehyde molecule get added into the carbonyl group of this first aldehyde molecule. That is, here this alpha hydrogen atom and this remaining CH2COH group get added across this carbonyl group. Now here breaking of this bond takes place. Electron pair gets shifted on this carbon atom, and this is negatively charged carbon atom get attached to this carbonyl carbon. Then electron pair shifts on this oxygen atom, and this oxygen get attached to this hydrogen atom to form H, C, H, H, C, OH. Now this hydrogen atom is from this aldehyde or acetaldehyde, that is this alpha hydrogen atom. Then here, right here, this hydrogen atom, that is this hydrogen atom is written here, and then here CH, C double bond OH, that is this CH2 C double bond OH. That is addition of this acetaldehyde molecule takes place across the carbonyl group of this first acetaldehyde molecule to form aldol. This compound is beta hydroxyaldehyde or beta hydroxy acetaldehyde. Why this compound is called as beta hydroxyacetaldehyde? Now look here, this is aldehyde first group, and here this carbonyl group is attached to this carbon atom, which is alpha carbon atom, and this alpha carbon atom is attached to beta carbon atom. Now next is gamma, delta, etc. Now here at beta carbon atom there is presence of hydroxy group. Therefore it is called as beta hydroxyacetaldehyde, or it is also named as aldol. This is the aldol formation. Now this aldol formed during the reaction, when it is warmed, then it undergo dehydration. When this aldol is warmed, this is aldol, this is aldol, and when this aldol is warmed, then it undergo removal of H2O, and here removal of H2O, that is alpha beta elimination takes place. OH group from beta carbon atom and hydrogen atom from alpha carbon atom is removed to form H, C, H, H, that is CH3, C, H, double bond, CH, C double bond OH. Now here unsaturated aldol is formed. Now here alpha beta elimination takes place. Name of this compound is crotonaldehyde. This crotonaldehyde is a common name of this compound. We can give the IUPAC name for this compound. Now give the numbering from the end which is nearer to the functional group. 1, 2, 3, 4. Now there are 4 carbon atoms. Therefore parent alkane is butane. But there is double bond, therefore it becomes butene. B-U-T. Now position of double bond is at 2. But2-E-N. And there is presence of aldehyde group, therefore it becomes 1-Al. That is but2-En, 1-enol. This is the aldol condensation for acetaldehyde molecule. This reaction is also named as self-aldol condensation reaction, since both acetaldehyde molecule undergo aldol condensation reaction, therefore it is called as self-aldol condensation reaction. Second example, we are going to see the condensation of 2 acetone molecules. This is acetone and this is also acetone, first and second acetone molecule, that is 2 molecules of acetone. Now here this is first acetone molecule and this is second acetone molecule. Now here this second acetone molecule get added across the carbonyl group of first acetone molecule like this, that is this bond breaks, that is this hydrogen atom is removed like H plus ion, then this negatively charged CH2 group get attached to this carbonyl carbon Then this pi electrons of carbonyl group shifts on oxygen atom, and this oxygen atom get attached to this hydrogen atom. Here first addition of second molecule of acetone takes place across the carbonyl group of first acetone molecule. That is, this is addition reaction. And here formation of CH3, COH, CH3, CH2, C double bond O, CH3. Now this compound is ketone. Now here nucleophilic addition is carried out. That is, this is nucleophile, and addition of this nucleophile takes place, this carbonyl carbon. Therefore this is addition reaction, nucleophilic addition reaction. And in second step, this ketone undergo dehydration in presence. When it is warmed, then it undergo dehydration. This ketone, when it is warmed, undergo dehydration or alpha beta elimination reaction to give alpha beta unsaturated ketone or alpha beta unsaturated acetone. Now here removal of this H2O takes place from this alpha hydrogen carbon atom and from this beta carbon atom. That is, from beta carbon atom OH group is removed, and from alpha carbon atom hydrogen atom is removed to form CH3. Here alpha beta elimination is carried out to form CH3, CH3 double bond CH, C double bond O, CH3 plus H2O. H2O is written on the arrow, therefore negative H2O. Now name of this compound, or this compound is alpha beta unsaturated ketone. This alpha beta unsaturated ketone, the name of this alpha beta unsaturated acetone is mesithyl oxide. This is common name. Now we write IUPAC name of this compound. Give numbering from the end which is nearer to the functional group. 1, 2, 3, 4, 5. Now parent alkene is pentane, but there is double bond, therefore it is pentene. Now at 4 position there is methyl group, therefore it becomes 4-methyl. Then pent, P-E-N-T. At 3 position there is double bond, therefore it becomes 3-En. And at 2 position there is ketone group, therefore it becomes 2-O-N-E. That is, the IUPAC name of this mesithyl oxide is 4-methyl pent 3-En 2-O-N-E. This is also example of self-aldol condensation reaction. And in this reaction, that is, in this aldol condensation reaction, in first step, formation of aldol or ketone takes place. This is nucleophilic addition reaction. And in second step, elimination of H2O takes place. That is, removal of H2O, that is dehydration is carried out. Therefore, it is called as addition elimination. And nucleophilic addition elimination reaction. This is also example of nucleophilic addition elimination reaction. This is self-aldol condensation reaction. In self-aldol condensation reaction, similar molecules of aldehydes or similar molecules of ketones undergo aldol condensation. Now we are going to see crossed aldol condensation reaction. In self-aldol condensation reaction, we have seen that when two similar molecules of aldehydes and similar molecules of ketones undergo condensation, then it is self-condensation reaction. Now we are going to see crossed aldol condensation reaction. In crossed aldol condensation reaction, when two different molecules of aldehydes or two different molecules of ketones containing at least one alpha hydrogen atom when react with dilute base like 10% NaOH or KOH, then here 4 different products are formed. Now how these 4 different products are formed, we are going to see by example. Now here we are going to carry out the crossed aldol condensation reaction in between one molecule of acetaldehyde, which is acetaldehyde, and one molecule of ketone, that is acetone. This is acetone. Now here, when one molecule of acetaldehyde is reacted with one molecule of ketone or acetone in presence of 10% NaOH, then here 4 types of reactions are carried out. In this reaction, first acetaldehyde undergoes self-condensation with similar acetaldehyde molecule. Then this acetone undergoes condensation with same acetone molecule to form self-condensation product, and these 2 molecules undergo again crossed aldol condensation to form 2 different molecules, that is cross condensation product is formed. Now here we are going to see first, when first molecule of acetaldehyde react with second molecule of acetaldehyde in presence of 10% NaOH, then here formation of CH3, COH, H, CH2, C double bond OH. This is first aldol is formed. Now this second ketone or acetone molecule react with same molecule of acetone, that is second molecule of acetone, that is it undergoes self-condensation, then you will get here CH3, C, CH3, OH, CH2, C double bond O, CH3. Now then these compounds again undergo dehydration or alpha beta elimination reaction when formed. Then here formation of this crotonaldehyde, that is CH3, CH double bond, CH, C double bond OH. Then here formation of CH3, C, CH3 double bond, C, H, C double bond O, CH3. This is acetyl oxide. And then now these 2 molecules undergo cross condensation. Now in 2 ways cross condensation is carried out. First, acetone molecule acts across the carbonyl group of this acetaldehyde, and in second case this acetaldehyde molecule acts across the carbonyl group of this acetone molecule. Now first we are going to see addition of this acetone molecule across the carbonyl group of this acetaldehyde molecule. Now here, if addition of this acetone is carried out, then it becomes CH3, COH, H, CH2, C double bond O, CH3. Correct? Then when this acetone molecule or this acetaldehyde molecule when acts across the carbonyl group of this acetone molecule, then we will get here CH3, C double bond, COH. Addition of this is carried out across the carbonyl oxygen. Then a hydrogen atom goes to this oxygen atom, and this CH2COH group get attached to this carbonyl carbon. Then here CH3, COH. Then here CH3. This CH3 is written here, and then here CH2, C double bond OH. Now here these 2 cross condensation products are formed, which again undergo alpha beta elimination reaction by dehydration. Warm this, here also warm this, then you will get here CH3, C, H double bond, CH, C double bond O, CH3, and here you will get CH3, C, CH3 double bond, CH, C double bond O, H. In this way, 4 different products are obtained during crossed aldol condensation reaction.